All right. Hi, Van. How are you? Doing well. How was your time the other day? How was your time? Well done. Breaking the 20s. Good job. All right. So I just want to walk around and look. Everyone's just intimidated by me. So write your best guess of what this measurement is on the screen.
Measurement is 7.
No. Do you need a lab book? Oh, my laws. Another lab book right here. I know. It was Friday before a vacation and an assembly, so they all bounced. Let's be realistic here. Okay, just checking that front.
I'm trying my best. Also, I have a request.
Yes.
It's okay if you don't fill it.
That's weird. That has been requested by someone else in the room too. I'm not sure who. I have no idea. Okay, interesting that I didn't do the greatest job teaching this ever.
I can't see right here.
You can't see?
No, no.
Oh boy, I'm sorry. You'll wear glasses tomorrow. It's close, but not quite perfect. It's close, but not quite perfect. Yep. Why were you so scared? You had it right. Okay, here we go. The majority of you, and I mean this out of love, but you got it wrong. Almost all of you. So that just means that I failed you. If everyone sucks, that's usually the teacher's fault. So I'll take, don't pick on me. I'll take the L on this one, but I'm going to reteach it and make sure you know what you're doing from now on. So when we do significant figures, we need to report every number we know and one more that's a guess. Right, Matthew? You had it right. It's everything we know and then a guess. Let's estimate it. So if you look at this picture, we know it's 100. We know it's 110. We know it's 113. We also know it's a 4 because it's not past the 5. So I know it's 113.4. And then it comes down here. And this one's hard if you don't have your glasses on today. But we do know that this is between the 7th line and the 8th line. So we know this is a 7. And everyone had that. That was rock solid. But then we do one more number that is an estimate. So it's not quite half. So I'd say it's a 3, a 4, or a 5 personally. Now, if you put 0.475, 0.479, they're all fine, but you have to have 6 total digits. Did you lose it, or were you not here either? Oh, never mind. Perfect. Okay, thumbs up if that made sense now. Okay, that is not a ton of thumbs. So let's go here real quick. Turn to page 13, I think. Page 13, it has 2 homework problems at the very top. Oh, I'm here for you, Liberty. I'm here to ruin your lives. Right here. So on page number 13, do you see the 2 rulers? Let's practice those. All right. So write the number for this measurement and the number for this measurement, and let's see how you do. So just write them right by it. My fault. That's my fault. It's page 14. I apologize. So you're just telling me what these gray bars measure. Page 14. I like your shoes. Wow, both. Are they brand new today? Both of them? How are yours so white? Magic.
stuff we spray on them.
Scotch card.
Oh, you have to put, how many numbers do you have to put on this one?
Oh, okay. All right, my friends. Once again, as I walked around, a lot of you were incorrect. That's why I called Officer Thomas here. I'll take care of those people that got it wrong. Now, as I walked around, a lot of you have the same amount of numbers for both measurements, but that's not how it should be. If you were forced to say you have to measure to 1.5 as accurate as possible, or you're going to fail my class, which ruler would you choose? The left one, because it has more things, right? This one can measure more accurately, so it has to have more numbers in the answer. So let's look at it. We know it's 1, but not 2. So we know it's 1 point something. We also know it's around the 4th, but not past the 5th. We know those two values. So what do I do now? I estimate or guess. That's fine. 1.41 instead. I apologize for writing that. Okay, I put a 0, Liberty put a 1. Was she wrong or me wrong? No, we're both right, Liberty. Okay, looking at this one.
One of us is wrong, but it's not me.
It's me. I know it's what value? 6. Do I know anything else about it? Nope, so I guess. I'm going to say 6.3. Would I put 6.30? No. I wouldn't do that because that would mean I do know it's a 3, but that's my guess. I would not. Okay, these are tricky. I'm going to give you a little quiz on it tomorrow because you guys, this class seems a tiny bit off on it compared to the other ones. Okay, what's that? Well, if I give you a quiz, it's not punishment. It's me finding out who needs more help. Okay, it's definitely, and by the way, if I refer you to B time, it's not punishment. It's so I can help you do better on your test. So if you get a referral from me, please show up. All right, don't go to Beto's or the North parking lot. All right, fair enough. Stay on page 12 for a minute because I just want to have a short conversation. Well, I guess you're on 14. Turn to page 12. On the top of page 12, where it says measurement practice, I want you to put homework. It's okay. Anytime in our lab books, the last few pages, it will say something practice. That's where your homework starts. Now, please listen. If you are with me and attend every day, you'll have 99% of your homework done in class. You'll never have to do it at home. So the only time you have to do it at home is if you're absent or if you didn't get it all done while the time we practice it in class. So like today, we should be done with 1 through 10. Now, not now, we'll do it together in a little bit. And then we'll do 11, 12, and 13. And then we'll have, we already just did 14 and 15, right? So we will do it in class, but if you miss or you don't get done when we do it, then it's homework. When you turn the lab book in, everything from page 12 on should be filled in. You all right with that? I promise we'll do most of it together though. Okay, so this took a little longer. So let's just go and jump into the notes on page number 2 now. We will come back to 12 eventually. Just turn to page 2 if you would. Now, soccer team, you'll have to do sometime because you'll miss. But it's great. Look right here. If you just looked so mad. If you scan that, that will take you to the video of all the homework. Okay. On all of it. Okay. Page 2. page dos. There you go. Okay, so we are now on what is called experimental error. Now, one thing kids really don't like about this class is that we jump around different pages. You got to work through that. Like, you're allowed to not like it, but I don't actually care. So just pay attention. You should be fine. I'm sorry, it's hot. All right, so here we go. Experimental error right here on page number 2. It is defined it's calculated by subtracting the accepted value from the observed value. All right. Ooh, that's going to sound weird on the video. Okay. So the experimental error, we don't really actually do that often. We worry a lot more about the percent error. Because if you go home to your parents and you say, hey, I only missed 2 on my test today, they are probably going to say, out of how many? Because missing 2 is extremely vague. We don't know what that means unless we know out of how many, right? Well, experimental error is just saying, I missed 2. Percent error is saying, I got 80%, meaning you missed 2 out of 10, or I got a 98, or I am terrible and I got a 0. It was out of 2. So this is what experimental error is, how many you get wrong on a test. But what we really care about is the percent error, which is defined in the next couple of lines. And that is the percentage error is the comparison of the experimental error to the accepted value expressed as a percentage. Now, I don't expect you to think of all that. But how many have ever calculated the percentage you got on a test? Raise your hand. Okay. You just took what you got and divided by what it was out of, right? The only difference now is if you did that and you found you got an 87%, the experimental error would be negative 13%. Because you should have got 100, but you were 13% lower than 100. That's all we're doing. No? Not good, Bree? Good? Okay. All right. So there is a little bit of math, but we can do it. Now, every year, all year, this question comes up. I teach it right here, please. The sign of the error. When you do this math, you might get a positive and you might get a negative value. That's completely normal. All right. If it's positive, that means that your experimental result was higher than what it should have been. And that's like you got extra credit on a test. If you got 104% on your test, then your error would be positive 0.4. Now, error sounds like a mean, bad thing, but it's just a value. All right, negative means you got too low. So if you got 87% on the test, you wanted 100, you were negative 13% under what you should have been. So don't panic when you get a negative sign. Okay, here is the equation. Percent error is equal to the observed value. That's what you get. If you're doing a lab or you are taking a measurement, the observed value, this means you, what you see. That says you see. I don't even care what you think it says. All right, with your own eyes. Or if the problem's written out in your homework, it will say like a student measured and got this. That would be the observed value. The accepted value in a problem is typically written as the book or the literature value or the teacher stated or you should have gotten or whatever. That's the accepted value. So in the example on the test, the observed would be your score. The accepted would be what the test was out of. Fair enough? Okay, this equation is going to be used on our homework problems on page 12. So let's turn to page 12 and work through these problems, one or two of them together, and then I'll give you some time to do them on your own. So the first section of the homework is called percent error. What time do you guys leave today? Soccer? 7. Oh, turf? Okay, so if everyone will look right here on your lab book, you have this QR code, right? If you scan that, you don't need to now, but it takes you to a YouTube playlist that explains how to do all of these. So if you're ever at home and you're stuck, scan that and it'll take you where you need to be. Hold on. That was wussy, but it helped me remember my hot plates on, so that was a good thing. There we go. All right. Next. So if you ever get lost, there's your homework help. Okay, percent error. Let's put the equation we're going to use. Percent error was the observed minus the accepted divided by the accepted times 100. Okay, we're going to use the same equation on all 5 problems. The only tricky part is to figure out which is the observed and which is the accepted. So tell your partner real quick. If it says the literature value, tell them, is that the observed or the accepted? Tell your partner, not me. Literature value is the, tell your partner. Okay, the first answer I heard was, I don't know. That makes me sad. Because the book and literature mean the same thing, right? The book is the accepted value. The literature is the accepted value. So the literature value of this is 57.9. That's your accepted. If a student determined, or I could restate that, if a student observed the mass to be this, well, then that would be the observation, right? So now I'm ready to throw those in. I have my observed, sorry, my accepted and my observed. Plug them into that equation. You'll need a calculator. You can use your phones as long as you're mostly on your calculator and not on your Snapchats. So plug it into that equation and see what you get. That's great. Perfect. Yeah.
Oh, okay.
All right, who has an answer? Raise your hands. Good. Oh no, Colville. Good. I'm sorry. Okay. If you'll check with your partner, a little bit something wrong. You should get 2.93 or 94. Who has that value? Raise your hands. Okay, if you have in the 5,000s, it was just a typing problem. So type it in again and see what if you get it right. You can round it. All right, I would at least usually report every answer with 2 decimal places though. All right. Next, number 2. I'll do number 2 with you and then we're moving on. At 20 degrees Celsius, the solubility of chloride is actually 34.7. Does that sound like the accepted or the observed? Tell your partner. Actually is the accepted. That's like saying the test is actually out of 80. All right. A laboratory experiment says it's 32.3. So that's our observation. Okay, plug those in and see what you get. And don't stress if it's a negative value. Oh boy. Okay, perfect. See if you can do these now. You got it, amazing. Okay, if you got negative 6.2-ish, then you're golden. Uh-oh. No? 6.92.
Oh, yeah.
6.92, sorry, it was upside down. And anyway, you good now? 6.9. If you got negative 6.9, you're golden. Try and do numbers 3, 4, and 5. If you didn't get that right, I'm going to work through it on the screen. But if you don't need it, you don't have to watch. So I'm doing number 2 only if you got it wrong. So it's O minus A. So 32.3 minus 34.7 divided by the accepted 34.7 times 100. Most likely, if you got it wrong, it was a typing error in your calculator. You must take 32.3 and subtract 34.7, and you need to hit equals. That will give you the answer that you then divide and hit equal, and then multiply by 100. Your iPhones, if you don't do it in that order, it will divide these two numbers, subtract that answer from this, and multiply it by 100. And this is always 1. So just make sure you type it in that order. Subtract, hit equals, then divide. Okay, there's one of them that's pretty easy. You don't have to like do any math. Good job. You need a calculator, Bo? All right. Raise your hands if you're done with 1 through 5. Okay. Raise your hands if you think you can do this on a test. You're good. It's okay. I'm just glad it wasn't like your mod or something like that. That would have been awkward. Not that you have one. Okay. But I just haven't seen a Hot Wheels car fall out of a kid's pocket lately. It's cool. I'm not as cool as you. I'm not a Peterson. I had a ton of Hot Wheels. Actually, I still own them. I gave them to my kids. What's that? Sure. When we going? All right. So raise your hands if you're done. Was anyone confused on number 5? If there's no error, then there's 0% error. If what you got was what you were supposed to, perfect. And 0, that kind of sounds mean, but 0 is what you want. It's like your driver's ed test. Like you got 0. You're like, sweet, I missed none. All right, right, Liberty. Oh wait. Just kidding, she did amazing. I actually thought you got 100, and then I remembered you didn't. That was a disaster. Okay, moving on. Raise your hands if you think you can do these problems on the test if I give you the equation. Good. You're going to prove it tomorrow. What's that? FYI, Liberty's a great driver in the driver's ed car. I have no idea about her personal driving skills. She was great in the driver's ed car, so don't let me down. Okay. Bree, you don't have to move on, but fantastic. Overachiever. Okay, let's move back to page number 3 now. Oh, wrong direction, Thomas. Back to the notes. That's great. We're going to learn how to do that now. I appreciate that you guys are overachieving. Did you speed? Did you get a ticket? Accident? Oh, we're good then. Okay. All right. Page number 3. Thanks, Odessa. Addie. You don't really care either way, do you? Oh, you do care. Sorry. Addie. You're not going to like toilet paper my house tonight, are you? You're not going to toilet paper my house, are you?
No, I don't know where you live yet.
Okay, perfect. Yeah. Okay, here we go. At the top of page 3, it says units. You ready? You should all know that almost all of the matching terms comes from page number 3. Almost all the matching terms come from page number 3. Now, a lot of them I feel you've learned before, like the meter. How many have heard of the word meter? If you're not raising your hand, you're too lazy. Everyone's heard of it. It's called the unit of length. So matching terms are almost all from page 3. This is a matching term. The meter is the SI unit of length. That is the matching term. Now, those matching terms can be found by scanning the thing on the front cover or the thing right here, probably. This one might actually be to the notes, but whatever. So the meter. Then we will learn that there are 100 centimeters in a meter. You probably learned that in whatever science class you had in 7th, 8th, or 9th grade. You also should hopefully know there are 100 cents in a dollar. Centi is the prefix for 100. Okay, next, area. This is a matching term. There's 2 of them. Area is the number of squares that fit in a 2-dimensional object. That's one of the matching terms. But there's 2 on this screen. They're not really that bad. Oops, I keep doing that, Tom. So area is defined as the number of squares, but area on the matching terms, you have to know its unit is centimeters squared. I'm hoping this goes better than last hour. So the unit is not usually super hard to remember because look, area is the number of squares. What do we call it when we raise something to the 2? We're squaring it. Whew, that didn't go well last hour. We're squaring it. So there are ways to remember things that really are that hard. If you remember the definition or the unit, you should be able to remember the unit or the definition. Okay, volume is a measurement of the number of cubes. It's length times width times height that fit into a three-dimensional object. All right, and just like area, there are two here. There's the definition and there is the unit. But if we have three-dimensional, that means we have a 3 as my exponent. So they definitely do tie together, the unit and the definition. Okay, we good? Okay, the liter is the SI measurement of volume. You're awesome. Someday you'll believe it. All right, so the liter, the SI measurement of volume. I get tired of walking around, so I sit down sometimes. That doesn't mean you're in trouble if I sit by you. Good? We friends? All right. So this is also a matching term. The liter, it's the SI unit for volume. I don't know why, but I really find this satisfying. I don't like that though, but oh well. It's illegal. I'll just bug you even more. Okay, sorry. Next, there are 1,000 milliliters in a liter. The prefix milli references 1,000. Milli means 1,000 smaller than whatever you're saying after it. So if it's milliliters, it's 1,000 smaller than a liter, or 1,000th of a liter. I can do this all day, kids. All right. Oh, this is important. It's not a matching term, but you should know a milliliter is the same as a centimeter cubed. That's kind of weird, but the definition of a milliliter is the following. The definition is if you drew a cube, not drew, if you made a cube that was 1 centimeter wide by 1 centimeter tall by 1 centimeter deep, then the volume that would be in here would be a milliliter. I don't know why I put an extra M on the M, but anyway. All right, Bree, who you playing?
Oh, sorry.
Oh, okay. Looked like you were doing well. All right, so really they are the exact same unit. A milliliter is the same as a cubic centimeter. All right, matter, matching term. Matter is anything that occupies space. That is a definition you should know. Now, there's a second definition on here that you should know, and that is the definition of mass. Mass is the amount of matter present. So matter is stuff, mass is how much stuff you have. We all right with that? I know I'm going fast, but I'm sure you'll study. You'll download the cards, you'll print them, you'll have them on your phone. You're going to study your butts off for the matching terms, right? Thank you, Matthew. Probably not. Just okay. So we got one person being honest and one person that wants to go to a car show with me. Yeah, I like it. Okay, here we go. Next, the SI unit of mass is the kilogram. You guessed it, folks. That's a matching term. I was in Mr. Burt's class today, and guess what they were studying in Weber State 1010, whatever it's called. The exact same crap. I mean, stuff. I mean, awesome information. So you'll learn this every year of your life. So the SI unit of mass is the kilogram. The kilogram is defined in a really odd way. Nowadays, it's defined in like the most complicated way of all time. But it's defined as the mass of 1,000 centimeters cubed of water at 4 degrees Celsius. Now, what that really is saying, I know it's kind of confusing, but the kilogram is the mass of 1 liter of water. Because if you have 1,000 milliliters, you have a liter. So it's really very convenient how kilogram, volume, density, all that do relate to each other. All right, I'm having fun. I hope you guys are too. There are 1,000 grams in 1 kilogram. The prefix kilo means 1,000 times bigger. Wow, I'm really just digging the highlight thing today. Is it getting old? Don't answer that. But my highlighter and Bree's shirt match really well, in case you guys are wondering. All right, next up. Density measures the amount of matter in a given unit of volume. If you were forced to guess, you would guess this is probably a what? Okay, never mind. You would guess it's a matching term. Like almost everything on this page is a matching term. And that's a lot of stuff, but once again, the flashcards are already made for you on Quizlet anytime you want them. Okay, the units for density are grams per centimeter cube or grams per milliliter. They can be both because they both mean the same exact thing. So that's whack. But why don't you just have a short discussion with your partner so I can walk around and feel like you're engaged and say, how is it possible that those two things with different letters mean exactly the same thing? Ready, set, con, talk. Oh, did you hear Ivan? What did he say? He did say they're the same. It's all right. Yeah, it's nice, huh? Hover and then push. So watch up there. And when you want to be, then touch. Okay, you keep doing that, that's fine. So if you look, Ivan Crane had a perfect answer. You willing to share it? Boom. From definition number 2 or whatever, we learned that a milliliter is the same as a centimeter cubed. So a gram per centimeter cubed or a gram per milliliter have to be the exact same thing, right? It is crazy, right? Will you hit the top right button? It's on the left, or there you go, but it's right there. Okay, keep going. Keep going, keep going, keep going. There you go. Okay, number 5. We're going to fill this out. Water. Now, Bree is enjoying highlighting as well because it's extremely satisfying, but this is not a matching term. It's fine. No one cares. Water has a density of 1 gram per centimeter cubed. And that is awesome because math with 1 is amazing. Who can multiply by 1? Liberty can. Everyone. We can divide by 1. It makes it very nice. Okay, if an object is more dense than water, it will sink. Okay, like a rock, they all sink. Well, not all, but 99.9% of rocks sink because they have a density much higher than 1. So they go down. All right, next, please. All right, a sunken object, so once it's underwater, if it was more dense, it will displace its volume in water. So if you throw a rock in the ocean, the whole ocean's volume increases. Yeah, one little rock it has to raise the elevation of the entire ocean. One rock. But not by much though, right, Claire? Yeah, there you go. Yeah, dig a giant hole and put that dirt somewhere else. You could unflood things. Okay, Bree, you might be going a little bit too ham. All right. Now, if an object is less dense than water, it will float. A floating object will displace its mass it's okay. So turn the wheel for me. Nope, the wheel. Other way. There you go. A floating object will displace its mass in water. So a gigantic like aircraft carrier is floating because it's pushing away its same exact mass in water. And so then that pushes the boat up. Okay, next, please. All right, just a couple things, and then we're gonna do some more homework. Did she go too far?
No.
Mass. That one's mass
This one's math.
and less. It's kind of addicting, isn't it?
Yeah, it is.
All right. Now we're just gonna fill these out. We already said the meter and kilogram, right here, meter. All right, some of these we didn't talk about, and look, we got to go to the next slide because I spelled ones. I'm just a disaster. That's what my student teachers basically said all day. Why isn't it scrolling? What did you do? We're good. I got this. There we go. I spelled Celsius wrong. All right, so for length, we use the meter.
Is that how you spell it?
No, the I before.
Never know.
It doesn't matter. No, heat and temperature, they feel like they're the same thing, but they're super different. Heat is a measurement of energy. Temperature is just a measurement of how fast particles are moving when they hit a thermometer. We'll learn about it, but here we go. So we got meter, gram, joules, liter, and Celsius. Sorry. Okay, how many of you have, let me make sure this works before I teach you this life hack. I assume it works on a phone. You will most likely never need this hack, but I'm going to teach it to you anyway. Okay, how many of you know how to type in a degree symbol in your phone? 1, 2, 3. Okay, so here you go. It will come in handy one time in your life at least, and you'll be grateful. You've learned nothing from me except for how to put a degree sign. So if it's 50 degrees, you type 50, and then you long press on the O, and it lets you select the degree sign. You with me? That's important stuff. Are you reading my text of Rollins? Okay, because what's that? Because tonight you're going to play a game and then your BFF's going to say, how was it? You're going to say, it was great, but it was like 93 degrees. Bink. And now you know how to put the 0 up top. Yep. So you're welcome for all the life hacks I teach you. Okay, now. You're welcome. I'm here for you. At least it's 1. That is greater than 0, so we can celebrate. All right, my friends. Just kidding. You're going to learn a lot in this class. Some stuff, not exactly chemistry, but you're going to learn, I promise. I did finish that page. Oh, I did not. I got this. I'm sorry. You're right. So I forgot. I'm with you right now. You ready? Kilo. Put the number 1,000. Sorry. A kilo is 1,000 times bigger. Centi is 100 times smaller. Milli, 1,000 or 3 zeros. Never mind. Yeah, 1,000 times smaller. Micro is 1,000,000. A 1 with 6 zeros behind it. Okay, I apologize. Now turn to page 12. Let's do some homework in class. What's classwork instead of homework? Now, some of you already did it. I'm proud of you. Okay, I'm going to teach you something for 6 through 10 that might be helpful if you suck at algebra. Raise your hands if you've ever gotten a problem wrong in algebra. Yeah, right. Okay, so everybody. All of these, we're going to calculate using the density equation, but we're not always just solving for density. We might solve for mass or volume. So there's a little trick that I'll teach you called the Tom circle. Now you don't have to use it. I'm just trying to save you from screwing yourself over because you don't do algebra right. So if you would, on that page, draw a circle with a line like that and a line like that. Yeah, just that's a perfect spot for it. All right, now that circle will help us with this equation. We know density equals mass divided by volume. We know that, right? Okay. This circle, I learned it in college in physics class. In physics, there's 1,000 three-variable equations, and you have to solve for them a lot. And you can screw up. They're not that hard, but this circle helps. When you see an equation like this, you take the value that's on the top of the fraction and you put it here. And then you take the things that aren't on top and put them in the bottom. That says density, and this is volume. Okay, now let me show you how this works. It's just moving the variables around for you. So follow my logic here. When I use the circle, I cover up the thing the problem is asking me for, and then it gives me the equation. So if you look, density, if I want to solve for that, I cover it up, and I'm left with mass on top of volume, or I'm left with mass divided by volume. This is a divide sign. If they're next to each other, you multiply them. Sort of with me? So now, if I ask you in the problem to solve for volume, you cover volume up, and it gives me the equation is mass divided by density. Volume is mass divided by density. So far, okay? Okay, then the last one, if I want to solve for mass, I cover that up, and I'm left with density times volume. Now, all I'm doing is rearranging this to solve for what I want, but I'm doing it without thinking. And on tests, the less you have to think, typically the better you do. So it's just there as a help. It's not required, but it's there to help you. Now, just as a review, the units for mass are typically grams. The units for volume are milliliters or centimeter cubed. And then density is the one where it has both of them, like grams per milliliter or grams per centimeter cubed. So now we can look at every problem. We can read it and see what it asks for, and then just plug it in. You ready? Okay. You don't have to have the stuff written in red unless you really want it. I see a lot of people squinting. I'm sorry. Let me, if you want it. Okay, that was a failure. That was really a failure. Now, half the problems most likely that my writing sucks. Make it bigger, it looks even worse. All right, here we go. Let's do this problem. So number 6, I read the problem first and it says, what is its density? So my equation, that one just says D is equal to M over V, right? M is the grams. So 16.1 grams, and you don't have to put the unit when you type it in, obviously. 16.1 grams, and then the volume, that's the unit of centimeter cubed, so you have 0.75. So you just divide, and you get type it in again. Can't be smaller, it's got to be bigger. I think you times. Yeah, you multiplied last time, I'm positive. There you go. Okay, you should get 21.4. Thumbs up if you got 21.4. Okay. And it wants density. The unit of density would be the gram over the centimeter cubed. Okay, number 7. We read it first. Tell your partner what 7 wants you to solve for. which of the three things does 7 want you to solve for? Some of you've already moved on. It's fine. You just say that word. It wants the volume, right? So in my Tom circle, I cover up volume and I'm left with, oh, okay, well, pretend volume's gone. I'm left with mass divided by density, right? So I go to 7. Why is it not scrolling? And I divide them. I take the mass, which is grams again, 6.38. I divide it by 2.65, and I have my answer. Okay, so let's go back to the very start of the hour. And when I talked about homework, I said the only time you have homework is if what? If you don't finish. So if you didn't get through 1 through 10, just finish those tonight if you would. Most of you should have, it's like one more problem, right, Liberty? Okay, 2. If you're struggling, go to the YouTube link and watch it. It works through almost all of them. Hey, when you get up, thank you. Will you push your chairs forward and straighten your desks?